Okay, I'm going to work through parts of pages 21 and 23. Let me know if you have any questions. Okay. So if they give you a derivative graph, like in this case, f prime of x, and they don't give you a formula, and they're asking you to find the antiderivative at a point, then you got to use this formula here. There's a my final position, or any final position I'm looking for, is equal to the initial plus displacement. So if I want to find, so basically f of b is equal to f of a plus the integral from a to b of f prime of x. And I have that formula on page 24 as well. Yeah. Final position equals initial plus displacement. There's also different variations. You can also say final velocity equals initial velocity plus the displacement of acceleration. So if I want to find f of 4, my initial basically is the given, okay? The given point. So if I want to find f of 4, I got to start at f of 10 because that's what's provided for me. And then I got to bridge the gap between 10 to 4. I know that this is backwards, so the tendency is you want to say from 4 to 10, but initially you're going to have to follow the rule that's provided. So whatever the lower bound is, it needs to match your starting point because I'm starting at 10 and I'm moving to 4. Now, if you realize that you still want to flip the bounds, you can flip the bounds, but then you can remember that there's a negative that has to come out if you flip the bounds. So all these areas under the graph, I want to highlight them. They are between the graph and the x-axis. But I know there are other shapes, but we don't care about those other shapes, right? Maybe see some triangle here, but you're only looking at the region between the graph and the x-axis. So let me highlight them here. These are all triangles, 1/2 base times height. So this is -4 here. 4, 4. F of 10 is 5 minus the integral from 10 to 4. Sorry, 4 to 10. Sorry, I changed the sign, but I forgot to change the bounds. So it's 4 minus 4 minus 4, which is -4. So f of 4 equals 9. F prime of 4. F prime of 4 is just the order pair, because this is the f prime graph. So f prime of 4 is just the order pair. It's going to be 4. Sorry, 7. Wasn't reading. So f prime of 7 is the order pair at 7, which is, yeah, so -2 order pair on the graph. So now f double prime of 7 is going to be the slope of this at this point. So that is a slope of down 4/2, so -2. So they're -2 for different reasons, right? F prime of 7 is -2 because that's where the order pair is, the y value. F double prime of 7 is also -2 because that is the slope, just happens to be numerically the same, but different reasoning. Part B, on what interval between -4 and 12 is the graph of f both increasing and concave up? So I can create both my slope and concavity sign line. My slope sign line, I know that anything above the x-axis is a positive slope. Anything below the x-axis is negative slope. Anything on the x-axis is slope 0. Brandon, that's the handout for today's class. So I'm going over the morning review from the previous packet. So my critical points is where slope 0, so -2, 2, 6, and 10. So we see from -4 to -2, we see the graph is clearly below the x-axis, so it's negative slope. And then the next interval here, positive slope above the x-axis. Above the x-axis, still positive slope. Between 6 to 10, negative slope. Between 10 to 12, negative slope. So now I can find my critical points for my points of inflection. Points of inflection for my second derivative graph sign line is going to be the peaks and valleys. So it will be 0, 2, 4, 8, 10. Now let's just look at the slope for concavity here. Positive slope means concave up, concave down, concave up, concave down, concave up, concave down. So keep oscillating, keeps switching back and forth. We're looking for places where our graph is increasing and concave up. So between -2 and 0, I see those two characteristics matching up. 2 and 4. That's it, right? So our function is increasing concave up on the intervals from -2 to 0 and from 2 to 4, because f prime of x is greater than 0, and f double prime of x is also greater than 0. All right, part C, sorry. Let j of x equals 4x squared times g prime of 2x. Find the equation of the line tangent. So we need to find order pair, we need to find slope. What rule is required here to get to the derivative, seeing how this is set up? Four x squared times g prime of 2x. Well, u sub would be for antiderivative, right? This is asking for the derivative. Anything stand out here? A little bit of chain, but there's something bigger here. There's a bigger product rule. Yeah, so product rule for the 4x squared and g prime of 2x. Do you guys see that? Those are two distinct terms, but then you're right. Within g prime of 2x, there's a little bit of chain rule. Right, so, but you start off with f prime g plus f g prime. And when you get to that g prime 2x, you can then involve its derivative. So 4x squared becomes 8x. G prime stays. 4x squared stays. When we get to g prime of 2x, the derivative is g double prime of 2x times 2. Now you're just gathering information for slope and order pair. So order pair, insert -1 in for x. So insert -1 in for x. I get 4 times g prime of -2, g prime of -2. I can just pull that information from the table. It ends up being -1. So 4 times -1 is -4. That's my order pair, -1, -4. To find my slope, I'm going to insert -1 into the derivative function that I've already built. Replace every x value with -1. G prime of -2 and g double prime of -2. I can pull from the table. I end up all the way with 40, and then finally point slope form. Yeah, the hardest part here is recognizing the need for product and chain rule, and then applying those rules to build the derivative. Okay. Next up, find the limit as x approaches 2. Now that's a really messy looking problem here, but the idea is that, well, we just plug 2 in, right? See what happens. If I can plug 2 into that limit expression and get a real number, then that's it, right? There's nothing more that I need to do. But if I get something else, then I need to make the appropriate conclusions, right? If I get a real number, then great, that's the end. If I get 0 over 20, that's a real number, that's 0. If I get like 20 over 0, then I would stop and say the limit doesn't exist. But if I get a 0 over 0, then that tells me that my limit is waiting for me, but I'm not able to find it just yet. Something is blocking my view. So with a complex problem like this, if we get 0 over 0, then we can do L'Hopital's rule, take the derivative of the top and the bottom, and then reevaluate, see if that will get us to a real number. So let's try part B. So first things first, replace every x you see with 2. Again, yeah, with L'Hopital's rule. Okay, I'm not going to take off any points because I don't think it's that big of a deal. But on the AP exam, if you're dealing with L'Hopital's rule, use arrows, right? Don't use equal signs. They're going to complain. Okay, so I'll replace every x with 2, and then let's look at see if we can get this down to a number here. G prime of 2. We look at our table. G prime of 2 is -5. G of 4. G of 4 is 4. So what do we get as a result here? What's e to the -5 minus 1 over e to the 5th? Or how similar are these two? Yeah, they're the same thing, right? Because e to the -5th, if I push that e to the denominator, so what happens with my numerator and my denominator? Right, so, whoops. So that's indeterminate form, right? But this at least gives us the green light for us to do L'Hopital's rule. L'Hopital rule says, take the derivative of the numerator and the derivative of the denominator separately, and then we can try the limit process again, or try reevaluating again. Okay, so what do you think the derivative for e to the g prime of x is equal to? What's the derivative of that? E to the u becomes e to the u times u prime, so g prime becomes what's the derivative of 1 over e to the 5th? Yep, e is a number, right? Yeah. G of 2x, a little bit of chain rule here, was g's derivative. What's the derivative of g of 2x?
Times 2x times 2.
Yeah. Well, let's try again. We have a different variation of the expression after L'Hopital's rule. And the hope is that now if we plug 2 into x's, we can get it down to something other than 0, 0. Hopefully this will produce a real number for us. But what if it gives us another 0 over 0? Then we know that gives the green light to do L'Hopital's rule again. Typically that doesn't happen too often, but just to give you an idea. again, G prime of 2 is -5. G double prime of 2, we look at our table, it's 3. G prime of 4, -2. So this is fine, or you can bring that E down to the bottom. Is there a time on the closed interval from -4 to 6 such that G triple prime of C is equal to 2/5? So this is basically playing on, well, I mean, if we look at we don't have a table for G triple prime, but we do have a table for G double prime. So basically, if we think of it as, well, if I can prove that the slope between the endpoints on the G double prime is equal to 2/5, then I know that there must be a slope of the G double prime where that value is 2/5, right? So I'm just basically playing with average with mean value theorem.
Just so that, and I don't have people to do all that. All of my people have advice.
And B tier you have taken against.
Mean value theorem. E through T is if we're trying to find absolute max or absolute.
Fine.
Okay.
Hi, how are you? Morning.
This is it.
That's it. The top copy is for you.
Okay.
And then there's blank copies and keys for the students.
The keys are underneath it. Okay, thanks.
Thank you. Okay, so I'm adapting mean value theorem. Derivative is the slope of the endpoints of the original, so the derivative of the second. So G triple prime is just G double prime slope. And it does give me 2/5. So by MBT, since G double prime is continuously differentiable, there exists a value where G triple prime is equal to 2/5 on the interval from -4 to 6. Sorry. Yeah, just completion. Okay. I'll pick up where I left off on Tuesday.